Today we're going to go over 6.2 divine rational expressions. Now, just like in multiplying rational expression, we worked with fractions. So when we're dividing, if you recall from chapter 1, in order to divide fractions, so example here, a over b divided by c over d, what we're going to do is to convert into a multiplication is basically flip the second fraction and then change from division to multiplication. And then you just follow the same process for multiplying fractions or multiplying rational expressions from the last section. Alright, in our first example, we have in our first fraction 3n minus 9 over 2n squared plus 6n plus 4 divided by our second fraction 2n minus 1 over 4n squared plus 2n minus 2. Now when you're dividing, simply the first step is to convert into multiplying rational expressions. So the first fraction will stay the same. And then I'm going to flip the second fraction. So 4n squared plus 2n minus 2 on the top, and then 2n minus 1 on the bottom, and now we have multiplication. Alright, now you can put the fractions together as one, but it's going to be one big fraction. If you do that, make sure you include parentheses on each term that you have here. Alright, what I'm going to do is factor each part that I see here. Alright, my 3n minus 9, I'm going to write it over here. I can factor by GCF because 3n and negative 9 are both divisible by 3. So basically it's 3 parenthesis 3n divided by 3 is just n. Negative 9 divided by 3 will be minus 3. Alright, if I look at the 2n minus 1, nothing in common, so I leave the 2n minus 1 alone. Next, let's take a look at 2n squared plus 6n plus 4. Now, there's three terms. If you look at it closely, all three of them are divisible by 2. So I'm going to have my GCF, my greatest common factor, to 2 outside the parenthesis. So 2n squared divided by 2 is n squared. Positive 6n divided by 2 is plus 3n. Positive 4 divided by 2 is just 2. And then from here, you can actually factor this. So again, if you're confused on what I am talking about factoring, I would recommend that to refer you to 5.2 factoring trinomials. So again, if you're confused when I'm talking about factoring this, refer back to 5.2 factoring trinomials. So when you factor this trinomial, we're going to have n plus 2 times n plus 1. So I finished factoring that. Next will be the 4n plus 2n minus 2. 4n squared, excuse me, plus 2n minus 2. Now you look closely, all three terms are divisible by 2. So I'm going to have my GCF outside the parenthesis. 4n squared divided by 2 is 2n squared. 2n divided by 2 is positive n. Negative 2 divided by 2 is negative 1. And then you can actually factor this. Again, refer back to 5.2 factoring trinomials. So it will be 2n minus 1 times n plus 1. And then if you want to double check, you can always FOIL to make sure it matches. So here's my 3 set of factors that I'm going to put back into the fraction. So since they're multiplying, what I'm going to do is I'm going to put them next to each other as one big fraction. So the 3n minus 9, I'm going to put this in its place. The 4n squared plus 2n minus 2, I'm going to put this in its place. On the bottom, where it's 2n squared plus 6n plus 4, this is what I'm going to put in its place. And then I bring 2n minus 1 next to this group of factors. Alright. Now, take a look at the common factors that we have here. Any common factors you have will become 1, or divide into 1. So let's take a look at our numbers. 2 and 2. That will both become 1. 2n minus 1, 2n minus 1. 1 on the top, 1 on the bottom. They both will become 1. And then n plus 1, n plus 1, 1 from the top, 1 from the bottom. Both of them will become 1. So, what we have here is, I'm going to write the ones I crossed out that became 1. So, we have 3 times n minus 3 times 1 times 1 times 1 over 1 times n plus 2 times 1 and times 1. So I'm writing this step by step to see where all the 1s are going to. And if you multiply the 3 times n minus 3, if you multiply these group of factors by 1, it will be the same thing. If you multiply by 1 again, still the same thing. Multiply by 1 the last time, it will be the same thing on the numerator. So in my numerator, it will be 3n minus 3. And I didn't put the parenthesis on the 3 anymore because, again, since it's just a number with a binomial factor, then you don't need the factors anymore. It's okay. In my denominator, 1 times my binomial n plus 2 will be n plus 2. N plus 2 times 1 will be the same. And then n plus 2 times the last one will be the same. So, and my denominator will be n plus 2. And that will be our final answer. So, it is very much alike to multiplying polynomials. Let me take that back. Multiplying rational expressions. And again, all I did was simplify by factoring by GCF, factoring trinomial from chapter 5, and then turn in or divide common factors into 1, and then anything that became 1 just multiply into 1. The ones that did not are left behind, and then this is our final answer. So the only difference was, if you start with division, flip the second fraction, and then change it to multiplication, and then follow the same process as multiplying multiplying rational expressions.